All right, in the last video we had a look at the proof of the quadratic formula. Now let's have a look at how we actually use it. So I'm going to skip just using the quadratic formula to solve equations, and I'll jump into probably what I think is one of the most useful places for using the quadratic formula, and that is when we are modeling using quadratic graphs. And so I'm going to show you how I use the quadratic formula to sketch a parabola. So the first thing that we've got here is these equations will work when I have the general form y equals ax squared plus bx plus c. So the y-intercept, as we already know, is whatever the value is on the end, c. The x-intercepts are using the quadratic formula, so minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now you need to try and memorise that formula before you get to year 12 so that it rolls off your tongue and you can just spit it out when you need it in exams. And then the final one, which I always forget, but if you can memorise this for the turning point, it can be quite quick and helpful when you've got ugly equations that just don't quite factorise or work nicely with whole numbers. So let's have a look at two examples. The first example we are going to do is to sketch y equals x squared plus 3x minus 1. Okay, what I like to do is always label in the ones just to remind me where it is, and then quickly write next to each of these values whether they are a, b or c. Now straight away I can look at this equation and I know that the y-intercept is equal to -1. The x-intercepts, now this is always occur when y equals 0, and if y equals 0 then I create the expression 0 equals x squared plus 3x minus 1. So this is where my expression is equal to 0. This is when I can use the quadratic formula. Okay, so for the quadratic formula, I always start by writing out what the quadratic formula is. Now, as I said, you want to try and memorise this, so the more times you write it out, the greater chance you have of memorising it. Then it is just a matter of substituting all of our values into the equation. So we know that b is 3, so it becomes -3 plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is -1. Okay, all divided by 2 times a. Okay, so now I've got this equation and it's just a matter of using BODMAS to simplify it down. So that gives me -3 plus or minus the square root of 9 plus 4, all divided by 2, which is -3 plus or minus the square root of 13 over 2. Now it can be a little bit tricky to sort of recognise what that is, but I do know that the square root of 13 has to be less than 4 and it's going to be greater than 3. Because the square root of 9 is 3 and the square root of 16 is 4. So it's got to be between those two values. So when I look at this, I know that I have -3 plus something that's bigger than 3. So that's going to give me a positive value. And then I have -3 minus something bigger than 3. So that'll give me a negative number. So let's actually have a look on the calculator what those two values give you. And you can see here I've already got it on the calculator, but I'll just go through how I enter it again. So I use the fraction button, and that plus or minus thing, I can't do that on the calculator in one step. So I have to type out the expression individually. And then to get your calculator, I use the approximately equal to sign, and I get 0.302776. Don't forget to round off. and I end up with two x values. One of them is x is approximately equal to, and I won't do both of them on the calculator now, you'll just have to trust me that I've done this correctly. Hopefully I didn't make a mistake. Anything's possible. Okay, they're my two x-intercepts. So I've got now my y-intercept and I've got my x-intercepts. The final thing I need to do is find the turning point, and I'm going to use this equation which I mentioned in the last video for the turning point. So this can be pretty handy. So same thing again, the more times you write it down, the greater chance you have of memorizing the rule. So let's start by writing the equation. And then my next step will be to substitute in those values. So b was 3, a was 1, c was -1, b was 3, and a was 1. Simplifying this expression, I get -3 on 2, and then -1 take 9 on 4, and to get this simplified on the right hand side for the y value, I need a common denominator, so I'll make that 4 on 4, and I end up with -3 on 2, comma, -13 on 4. Okay, so if I want to sketch the graph, now it's just a matter of putting all of those points on the axes and drawing a nice, neat graph. So y-axis, x-axis, let's label them off. We know that the y-intercept was at -1. One x value was at 0.33. The other x value was at -3.303. So let's just sort of like stick that down here. Now, because we're sketching, I don't have to worry about perfect scale. And what I'm going to do for these coordinates is I'm going to use the exact values. So it was -3 plus the square root of 13 all divided by 2, comma 0. And then this one was -3 minus the square root of 13 all divided by 2. Now I know that this has to be the bigger one because it's plus, and this has to be the smaller one because it's minus. Okay, my y-axis intercept is when x is 0 and y is -1. And my turning point was at -3/2 and -13/4. And I'm actually going to just sort of put roughly, there's halfway. I'll call that -3 on 2. And to try and make a symmetrical graph, I might have a couple of goes at doing this. But remember, I have mentioned that your shape is important. So if you do a bad job of it, please rub it out and redraw the graph so that it looks nice and neat. So this is my expression for y equals x squared plus 3x minus 1. There we go, that's the first example. Okay, let's have a look at a different one now, and we'll do a non-monic quadratic this time. So let's sketch the graph of y equals 5x squared minus 12x plus 2. The only thing that changes now is that my numbers aren't quite as small. Everything else goes the same. I like to label my A, B, and C. And don't forget, B is a negative value. That can trick some people sometimes, so don't mess that up. Okay, y-intercept, easiest part. Let's start with that. The y-intercept I know is always when x equals 0, or I know from the equation it'll be at y equals +2. And that's the coordinate when x is 0, y is 2. I'm giving a little bit more detail on that one than before. The x-intercepts is when y equals 0, and to do this I can use the quadratic formula, and again I'll write it out to help me memorize what that formula is. Okay, let's start substituting in our value. So our b value is negative 12, so it becomes minus negative 12 plus or minus the square root of negative 12 squared. Now I'm using the brackets to help keep track of my values. 4 times 5 times 2. And those brackets can also be useful when you're entering on your calculator to avoid making an arithmetic mistake. Okay, so negative 12 is positive 12, plus or minus negative 12 squared is 144. 4 times 5 times 2 is 20 times 2 is 40, all divided by 10. Which gives me 12 plus or minus the square root of 104 over 10. Now I also know that this 104 is the same as 4 times 26. So I can use my knowledge of surds to simplify that to 2 root 26, all divided by 10. And my purpose for doing that is now I can divide everything in that expression, top and bottom line. I can divide the top line by 2. I can divide the bottom line by 2. And that gives me 6 plus or minus the square root of 26 over 5. Okay, on the calculator, again, you don't need to get these approximate values, but I know many of my students in the past have liked the approximate values to help them visualize what's going on. So we had 6 plus the square root of 26 divided by 5. So one of them is 2.22. Better write that down before I forget. So it's 2.22. And the other value is so fraction 6 minus the square root of 26 divided by 5, and we get my second value 0.18. 0.18. And finally, the turning point can be found using the rule minus b over 2a and c minus b squared over 4a. So my b again was negative 12, so it's negative 12 over 2 times 5. And then c was, I have forgotten 2. So it'll be 2 minus negative 12 squared divided by 4 times 5. And this is a coordinate point, so I'll put it in brackets. Okay, 12 on 10, and then 2 minus 144 on 20. And if I work with my fractions here, that becomes 40 on 20 minus 104 on 20. And then I can simplify the first fraction to 6 over 5. And my second fraction becomes, sorry, that was supposed to be 144. Now it's 104 over 20. And simplify the fraction down, 6 over 5, and, minus, then it becomes negative 26 over 5. Last thing I've got left to do is sketch my graph. So nice set of axes. We're sketching, so we don't need a scale. I often talk about putting a scale on there because it can help you see what's going on. 2.22 and 0.18. So let's call that my 0.18. If that's 0.18, 2.22 is going to be up here. Roughly halfway has got to be my turning point. And the y value of the turning point is negative. I can also use what I've learnt earlier, that my quadratic expression is a positive x squared expression, so I know it's going to be a positive quadratic. And then rather than putting on my y-intercept first, I'm going to create a nice graph. Try and get that reasonable shape first, and then mark this one on there. So the y-intercept was when x was 0, y was 2. This first x-intercept will be the 6 minus the square root of 26 over 5, 0. My second one will be the 6 plus the square root of 26 over 5, 0. And my turning point was 6 over 5 and negative 26 over 5. And that's the graph of y equals 5x squared minus 12x plus 2.